Hi, my name is Jack Peterson.
Hi, I'm Evan Alexander.
And I'm Hunter Carlson.
We're all juniors here at Mines, and we're going to be presenting laser cutting today. Okay, starting with an introduction on what laser cutting is. It's a thermal process in which a focused laser beam is used to melt a material in a localized area. So it's really about channelizing energy into one kind of focal point that's used to move around in a part and take away the material. It's a highly accurate process, and thanks to the levels of control that are offered, you're able to cut really complex parts that you might not be able to quite as quickly. So, kind of what happens inside a laser cutter as it's being used. So, top right is the laser resonator. This shoots the diodes at the bending mirror, which then directs the diodes downward into the focusing head, where they're kind of all contracted into one single laser. It's mixed with the laser gas, which can be CO2 or nitrogen. It helps assist the process and eventually pushes it down through the nozzle, which is where the laser comes out of. And remember, lasers are really high energy and very powerful hot, which is how they're able to cut through metals such as steel.
So contrary to maybe what you might think intuitively about the name of laser cutting, the laser cutting machine actually uses hot flammable gases in conjunction with a laser to cut through materials. What will typically happen is you have a variety of different kinds of gases that will be ignited by the laser. Those will cut then through your material. There are different types of gases and different types of laser cutting, which we will get into here soon.
So there are three main types of laser cutting. The first is CO2 laser cutting, fiber laser cutting, and direct diode. So CO2 lasers are typically a gas mixture made of both carbon dioxide along with helium and nitrogen. And then this laser is then electrically pumped using an electric discharge. CO2 lasers typically emit a wavelength of about 10.6 micrometers, and they cut through materials much faster than fiber lasers, along with producing a finer surface finish at the end. CO2 lasers also are known for cutting through nonmetals and organic materials.
Next in the family of lasers is the fiber laser. Unlike the CO2 laser, the fiber laser just uses a focalized group of lasers without any mirrors to cut through materials. One thing that is different about the fiber laser from the CO2 laser is you can use it on typically more reflective materials, such as you can see here, copper, brass, and aluminum. Because of the lack of the mirrors within the actual laser machine itself, there's no risk of reflected lasers ruining the machine. In addition, the lack of mirrors make the fiber laser far more efficient than the CO2 laser, as well as limit any the scale of maintenance that you might need for something like this, because there's less moving parts, which means less risk of breaking parts.
So the third type of laser is a direct diode laser, which is the latest technology in the field of solid-state lasers. Direct diodes are composed of multiple lasers that have different wavelengths that are superimposed in one single beam. And unlike fiber lasers, direct diodes do not have a brightness enhancing stage, so they have a lower optical losses and a higher wall plug efficiency. These are pretty new, so they're not used quite as often. Some of the uses they're seeing right now is mainly just cutting sheet metal, but as they kind of progress more, become more efficient, they're going to be used a lot more for just general laser cutting. Here is a video example of a laser cutting of these tubes. I really like this example because it shows how laser cutting is automated. As you can see, the machine moves around the part and the laser moves up and down and does the necessary cuts. And it shows how laser cutting can be really efficient for designs like this, where you don't actually need, a human or someone cutting it themselves. You can have, this automated laser do it, and it produces a ton of parts in way less time than it would take someone to physically do themselves.
There are a few advantages to using lasers as opposed to maybe some physical CNC machines. The first of which being that you can cut a wide range of designs, anything from cuts out of sheet metal to part prototyping, and even mass manufacturing with laser CNC machines. They're fully automated, which means that a lot of time you can take out some of the dangers associated with making manual parts. And they also don't need to be finished after you've cut the parts. The laser handles that for you.
Over the advantages and disadvantages of laser cutting compared to mechanical cutting. As you can see, laser cutting is better with precision and tolerances. It's able to cut more intricate designs, more complex designs. There's no mechanical distortion of the part. There's less waste, less material cost with laser cutting, as well as less maintenance cost. However, mechanical cutting has the advantage in equipment cost and operational costs. This is due to the fact that lasers are expensive and they consume a lot of energy. Therefore, it's just an expensive operation in general compared to mechanical cutting.
So some limitations of laser cutting include a small range of suitable materials that can be cut, an inconsistent production rate, which just includes metal hardening, which can occur when the laser is really hot and kind of deforms the part, and then the metal rehardens into a part that you don't want. And then it also has high energy and material cost.
So here's another cool video that kind of shows two different lasers that are cutting the same exact part. Obviously the laser on the right is a lot faster than the laser on the left. As we mentioned before, some lasers cut faster than others. For example, the CO2 laser can cut faster than the fiber laser for, you know, thicker materials. So some lasers are better than others, and it just depends on, you know, what material you're cutting and how thick it is, and the complexity of the part that determines what the best laser is to use. Here's a pretty cool example of a laser cutting through some really thick metal. I'd say that's about an inch to an inch and a half thick, and as you can see, it takes the laser a few seconds, but it cuts right through, and here it's drawn out a circle with no problem. So it just goes to show that these lasers are really powerful, and they've been evolving over the years as technology's gotten better and better. And 20 years ago, they could never cut through metal like this, but you know, today they can, and as these lasers evolve, they'll be even able to do even more and really take over the industry. Here's the final product, all cut by the laser.